Hi, Assalamualaikum, and very good day. So we are from group CS510C, and today we are going to talk about properties of relation. So before we get started, I'm going to introduce you to my team. So first we have the group leader, Muhammad Hidayat bin Kasran. So his responsibilities are coordinate and oversee all aspects of the project. He is also ensure effective communication and collaboration among team members, and monitor project progress and ensure deadlines are met. And he's also going to manage project resources and address any issues or obstacles that arise. And next we have Amza bin Muhammad Azali. He's our system analyst. His responsibilities are gather information about the system, identify the system to ensure its effectiveness, and work together with system designer, which is me, to ensure the program meets the requirement. And last but not least, it's me, Azik Danish bin Hafiz. So my responsibilities are designing the overall structure of the program, preparing overall system, making sure design is usable, and work together with system analysts to ensure the program is dependable. Thank you. Alright, now so let's start with the background study. Relations are a key concept in both mathematics and computer science, and they play a crucial role in various applications like databases, graph theory, and even artificial intelligence. So what exactly are relations? They are essentially subsets of a Cartesian products, which means they define how elements within a set interact with each other. Now, to really understand how relations work, we need to look at three important properties: reflexivity, symmetry, and transitivity. So what are equivalence relations? For instance, it must satisfy all three of these properties. This ensures consistency in classification. On the other hand, partial orders only require reflexivity and transitivity, which helps in structuring hierarchical concepts. Now, verifying and computing these properties manually can be tedious and error-prone. That's where automation comes in. By automating these processes, we can significantly improve efficiency, especially in complex mathematical and computational tasks. So without further ado, let's move on to the next part. So one of the biggest challenges in working with relation is that manual analysis is both time-consuming and really prone to errors, especially when dealing with large sets and complex structures. To ensure properties like reflexivity and symmetry, and including transitivity, we need to compute closures, but this process can be tedious. And in fields like database normalization and even AI, inefficient decision-making due to these complexities can have a real impact. That's why an automated approach is very necessary. By developing a program to verify these properties can compute closures efficiently, we can improve accuracy, save time, and enhance application in both mathematical and computational domains. So with that in mind, let's look how we can approach this solution. I'm going to pass this to my friend.
Thank you for the previous presenter, Aziz Danish. So I am Amza, and I will continue the presentation about the algorithm of the system. So in the beginning of the system, user need to input data, which is the set of element and relation. So after user input the data, so the system will check if it is a reflexive property. If yes, so system will check the symmetric property, and lastly system will check if it is a transitive property. If it is no, so the system will compute missing closure, and if it is yes, so the system will tell the output result. And the system also have 3 buttons. So firstly is search button, reset, and also close. If user in the end of the system, so user can pick between search, reset, and close button. So if user click search button, so it will continue to request input data, or even when user pick the reset button, so it will start from the beginning. And if user click the close button, so the system will end. So we will continue about the interface of the system. So in the diagram above, actually the system will start with the title, property of a relation generator. So we will start with please insert the data into the checkbox given. And lastly, on the bottom of the system, we will show 3 buttons, which is search, reset, and close. Also on the other side, we got the property of relation and relation closure. So to see the output, we need to insert first the data. So in the diagram above, actually we have a set of data which is 11, 12, 21, 22, 33, and 44. So if we search, the property of the relation is reflexive, symmetric, and transitive, and the relation closure will show transitive closure 11, 12, 21, 22, 33, 44. The symmetric closure will also show 11, 12, 21, 22, 33, 44. And the reflexive closure will show 11, 12, 21, 22, 33, and 44. Next, we will talk about the analysis of the result. So, as the data shows 11, 12, 21, 22, 33, and 44. So, the properties of the relation will show if it is reflexive, symmetric, or transitive. And also the relation closure will show all the data given, which is if it's a transitive closure, it will show all the data set. Also same with symmetric closure and also reflexive closure. So I think that's all for me. I will pass it to the next presenter, which is Hidayat. So thank you.
Next, I will explain about our code system. This system is designed to evaluate and analyze relations based on specific properties like reflexive, symmetry, and transitive. On this slide, we can see the main code structure. The key function here is button 1 click, which process the input and check these properties. The results are displayed in the list box, including the closure operation for each property. Let's move to the next slide to see more details about implementation. Here, we dive into the core logic of the system. First, we have the parse relation function, which takes user input and convert it into a list of ordered pair representing the relation. Then we have specific function to check reflexive, symmetry, and transitive. This function iterates over the pairs and verify if the properties hold for the given relation. This breakdown allows the system to systematically process and classify the relation. Now, let's proceed to see how closures are computed. Next, we have functions like compute transitive closure and compute symmetric closure, which modify the relation to ensure it satisfies the respective property. For instance, the transitive closure adds pairs until the relation becomes transitive. This function provides a complete and accurate representation of the relation properties, making the system robust and reliable for analysis. Lastly, we have the format relation function, which transforms the relation into a user-friendly story representation. The function iterates through each pair in the relation, formatting it as curly bracket, bracket xy, and bracket ab to clearly display the structure of the relations. This step is crucial for presenting the data in a readable and intuitive format, enabling users to easily analyze the relationships in the system. By integrating the formatting, the system ensures that its output are as understandable as its operation. So this is our demonstration of our system, which is property of relation generator, and here user will insert the data, which is relation, and then and here we have three buttons, which is search button, reset button, and close button. And at the right side here the output will reveal, which is the property of relation and relation closure. Now I will insert the data or relation into this. As you can see here, there is a relation. Now if I click the search button, it will show everything, which is property of reflective. We have reflexive, symmetric, and transitive. And as you can see here, reflexive closure, everything is same because we have everything in this relation. We have all the properties. So what if we delete one, which is it will show the no symmetric, and as you can see at relation closure, it will add it by itself to 1 in order to, if not symmetric closure will add the relation, and if you reset, it will reset everything, and if we click close, it will close the entire system.
Thank you to Hidayat. As a conclusion, this project developed an automated program to analyze relation, verify query properties, and compute closure, reducing time, effort, and errors. It proved effective for large dataset and highlighted automation roles in improving accuracy and efficiency. The program has practical application in database management, network design, and education. The future enhancement could include integration with larger systems and improve usability. So that's all from us. Thank you.